All right, ladies and gentlemen, today we are going over lesson 5-6. This is the last lesson in chapter 5. So we're finishing up chapter 5, and we're going to be graphing inequalities in two variables. I did a quick kind of tutorial or whatever lesson on this right before your semester exams, but this is the actual lesson it comes from. So it's kind of a little bit of a review. So previously, we've been graphing inequalities that are on just a number line, right? Like if we have like this, and we had or inequalities and inequalities, compound inequalities, or you could just have regular inequality. So we could have y is greater than 2, right? So on our number line, this way, we could have 0, 1, 2, -1, -2, and we would find 2. We put a circle on it. Since this inequality symbol does not have a line under it, it means that the variable cannot be equal to 2, so we're not going to shade this in, but the variable can be any number greater than 2. So we're going to shade in all the numbers on our number line that are bigger than 2, right? And that's how we would graph a one variable inequality. So now we're going to talk about graphing two variable inequalities. So basically y equals mx plus b. What I want you to remember about this is when we write this, let's say y is, I'm going to say greater than, I don't know, I'll just write mx plus b. When you're reading this part right here, the y, or whatever one variable is on one side of the inequality by itself, that represents the shaded part of your graph. And I'll show you what I mean in just a minute. Okay? The line that we're going to graph is represented by this whole part, right? Y equals mx plus b. Remember how to graph y equals mx plus b? This is our y-intercept. This is our slope. So we start here and then we move rise over run, whatever the slope tells us to move. So this is how we sketch our line. And then the symbol in the middle not only tells us which way we're going to shade, but it also tells us whether our line is going to be solid or dotted. Solid or dotted. Okay, so I'll show you what I mean here. So y is always the shaded part. Then we have our inequality symbol, and if it has a line under it, then the line we graph is going to be solid. If there is no line under the inequality symbol, then the line we graph is going to be dotted. And then to actually graph the line, to know where to put it on our graph, we look at the equation on this side, right? Or the little expression here. Okay, so here they give us y is less than or equal to -3 minus 2. So this y is our shaded part. Our inequality symbol tells us that our line is going to be solid, not dotted. And then the line itself is -3x minus 2. This is our line. So we're going to start by graphing this. We're going to start by plotting our line. So on my graph, they've already done it here, but I'm going to go down to -2 and put a dot. And then my slope is -3, which is -3 over 1, right? So I'm going to go down 3 over 1. Down 1, 2, 3, over 1. That would follow our line. I can go backwards too. Backwards 1, up 1, 2, 3. Okay, so once I have 2 dots for my line, I can draw a line through it. To know whether that line is solid or dotted, I have to look at my inequality symbol. If it's got the line underneath, that means my answer is included, that my line is included with my answers. If there's no line underneath, it means my line is not included with my answers. Okay, and then I've got the shaded part here, and it says the shaded part is y. Y is less than or equal to my line. So the shaded part is less than the line. So if I'm looking at this graph and I've got this line, which way are all the numbers smaller than my line? This way or this way, right? All the stuff less than my line is this way, to the left. These are the negative numbers, okay? It goes down this way. So I would shade everywhere. What it tells you on this worksheet is if you're not sure which direction to shade, if you get confused with that part, it tells you once you have your line, just pick dots on either side of the line. So here in this example, they picked this point, 0, 0, and they picked -2, -2. So this red dot is on the right side of our line. This red dot is on the left side of our line, right? So we're gonna see which dot acts as an answer. And whichever dot acts as an answer, that's the side we're gonna shade, okay? And we already know which side is shaded, so we know which dot's gonna work. It should be negative 2, 2. So here I've got my 0, 0. This dot right here, it's not on the shaded side, so it should not work. So when x is 0, y is 0, I'm gonna plug a 0 in for x, a 0 in for y, which they've done here. And then just simplify. Negative 3 times 0 is 0, so it goes away. This side is 0, so basically I end up with 0 is less than or equal to negative 2. Is that true? Is 0 smaller than negative 2 or equal to negative 2? No, that's not true. So the solution 0, 0 does not work for my inequality. So I can't shade this whole side because that's included in the shading, right? And that's not an answer. So I'm not going to shade this side. Now let's make sure that a point on this side would work. So they picked negative 2, 2. No, I'll do a different color. This guy. So they plugged a negative 2 in for x, a negative 2 in for y. Negative 3 times negative 2 is positive 6. 6 minus 2 is 4. Over here they kept the negative 2. Is negative 2 less than or equal to 4? Yeah, it's less than 4. So that is true. So since that point worked, and it's on this side of my line, I know all these points on this side of my line must work, so I shade this side, okay? But again, you don't have to do that extra math, only if you're confused. Just remember that your y variable, so this guy here, represents the shaded part. So this is saying, oh, this still knows how to graph it. This is saying the shaded part is less than or equal to my line. All of my solutions will either be in the shaded part or on the line, since I have this line underneath here. Okay, so I think the best way to kind of get what I'm saying here is just to do more examples. So let's kind of focus in on that, and I'll show you what I mean. Okay, so for number 1, y is less than 4. Remember to graph this. Y equals 4. If we were to graph that, we just go up on the y-axis to 4. 1, 2, 3, 4. Put a dot. There is no x value here, which means I never cross the x-axis, so it's just going to be a horizontal line. Now, since it's an inequality, there is no line under here, right? So all my answers are represented by y. Y isn't equal to 4, so none of the answers on this line, or none of the numbers on this line will be part of my solution, okay? So instead of making it a solid line, I'm going to make it a dotted line. Kind of like that. But everything below that line is part of my solution. The shaded part is less than my line. So all of this, I shade. Everything, everywhere, not just a little bit. I have to shade my entire graph underneath this dotted line. So any point on the dotted line is not included in my answer, right? Any point below the dotted line is. So if I picked a point, let's say I picked this point right here, over 1 up 2. So doesn't really matter what my x value is because there is no x here. But my y value here, sorry, I said over 1 up 2, over 2 up 1. My y value here is 1. So I would plug a 1 in here. Is 1 less than 4? Yes, it is. That's true. So this point right here works as one of my solution points, right? If I picked this point up here, this is negative 1 up 1, 2, 3, 4, 5. Well, it doesn't matter what x is, that negative 1, because there's no x here. But 5 is my y value. Can I plug a 5 in here? Is 5 less than 4? No, it's not. So that doesn't work. That's why we're not shading anything up here. Only the numbers that make this a true statement are part of our solution. That's what we're shading, okay? Let's do another one. X is greater than or equal to 1. So I go up to 1 on my, over to 1 on my x-axis right here. There is no y variable here, so I'm never going to cross the y-axis. So I'm going to draw a vertical line through this point, and I'm going to make it a solid line since it has this line underneath my symbol. Okay, so there's my line, right? So how do I know which side to shade? Because remember, there's not just one solution to an inequality, there's infinite solutions. X can be any number greater than 1, right? So where's all the numbers greater than 1? Where are all of the points that have an x value bigger than 1? Are they over here? Are they over here? Well, in our x-axis, this goes up 2, 3, 4, and this way it goes down 0, -1, -2. These numbers are less than 1. These numbers are bigger than 1. So I'm going to shade all of this. Everything to the right of my line. I shouldn't have gone over my line there. Everything to the right of my line. Okay, so there's a couple things happening here. We're graphing our line. We're trying to figure out if it's solid or dotted. If it's got the line under here, it's solid. If it doesn't, like this guy, then it's a dotted line. And then I got to figure out my shading. And shading is just represented by the variable. The variable is the shaded part. This tells us what our line's going to look like, and this part tells us where our line is. Okay, let's do another one. I hope this is making sense. All right, 3x is less than or equal to y. Okay, the shaded part is the variable that's by itself. So I'm actually going to rewrite this just so we recognize it. I'm doing a different color. I'm going to put the y on this side, the 3x over here. Here the mouth is open towards the y, so I'm going to keep it open towards the y. I'm not changing anything, just writing it differently. Okay, so the shaded part is greater than or equal to my line. So how do I graph that line? Y equals mx plus b. Where's b? Well, there is no b here, so it's 0. So I put a dot on 0. And then my slope is the number in front of x, which is 3, or 3 over 1. So from 0, I'm going to go up 1, 2, 3 over 1. Right? And I can draw my line. Do I make my line dotted or solid? Well, it's got this guy underneath it, so I make it a solid line. Oops. Like this. It'll be a solid line. And so now I have to remember to shade, right? So this is saying the shaded part is greater than my line. So which direction is greater than? This way or this way, right? This is where it might get confusing. So this is where we can pick 2 points and plug them in. So I'm going to pick this point and I'm going to pick this point. So this point is at -1, +1. And this point is at over 2 up 1. So whichever point works, that's the side that I'm going to shade, right? So let's start with -1, 1. When x is -1, y is 1. 3 times -1 is -3. Is -3 less than or equal to +1? Yes, it is. 3x less than or equal to y. 3 times -1 less than or equal to 1. -3 less than or equal to 1. That is true. -3 is less than 1. So that is true, right? Let's just make sure real quick that this is not true. If this is true, then this is the side we shade on. Let's make sure this isn't true. So when x is 2, y is 1. 3 times 2 is less than or equal to 1. 6 is less than or equal to 1. Is it true that 6 is less than or equal to 1? No, that's not true. So that doesn't work. So this point doesn't work, only this side. So I'm going to shade everything on this side of my line. Every single point on my graph that's in the shaded region or on my line, since my line is solid, that's included in my answers. All of these points are solutions to this inequality. None of these points make this inequality true, but all of these points do. Okay? If my line again was dotted, that means everything in the shaded region would be a solution, but anything on the line itself, if the line is dotted, is not a solution. Okay? Next one, number 4. -x is greater than y. Okay? Remember, we want the plain variable by itself. That's our graph. That's our shaded part. So I'm going to rewrite this. Put y first, -x second. The mouth is open towards the -x. Okay? So here's my graph. The shaded part is less than -x. It's not equal to -x, it's less than -x. So let's graph -x. -x means -1x, right? So there is no y-intercept, that means it's 0. So I intercept my y-axis at 0. And then the number in front of x is -1, so that means from 0 I go down 1 over 1. Down 1 over 1, right? Here's where my line's going to be. Is it going to be a solid line or is it going to be a dotted line? There's no line here, so it's going to be a dotted line. I'm not good at drawing these. Okay, so it has to be a dotted line. And then we have to shade. And it says our shaded region is less than our line. So we should have to shade everything less than our line. If you're not sure which direction is less than the line, pick a point on either side of your line and see which one works, and that'll tell you which way to shade. Okay, let's do another one. X minus y is greater than or equal to 1. So let's get a variable by itself. And if there's 2, you want to get y by itself. If there's just 1, if it's just x, then x represents your shaded region. But if you have an x and a y, you want to use y as your shaded region. Okay, so here I'm going to add y to both sides. So I get x greater than or equal to 1 plus y. And then I need to get y alone, so I'm going to subtract 1. So I'm going to have x minus 1 is greater than or equal to y. And if you wanted to write it the other way, y is less than or equal to x minus 1, you can. I think I'm going to. Less than or equal to x minus 1. I literally just, it's the same exact equation. I just rearranged it. Okay, this is the same as this. I just flip-flop the sides. The mouth is open towards x minus 1, so I kept the mouth open towards x minus 1. All right, so now the shaded part is less than or equal to my line. So it's going to be a solid line. X minus 1, I'm going to go to negative 1 on my y-axis. My slope, the number in front of x, is just 1, so I'm going to go up 1 over 1. I could go backwards a little bit. Okay, it's going to be a solid line again, so I'm going to draw my solid line through these points. And then I got a shade, right? Well, the shaded part is less than my line. So which side is less than the line? Like this looks like it's more than my line, but it's going backwards. And I know on a number line, these numbers are negative. So is this stuff negative or is it going forward? Is this positive or is it going backwards? I don't know. So I'm going to pick a side. I'm going to pick 0, 0, and over 2 down 1. 0, 0, 2, negative 1. And I'm going to plug both of those in and see which one solves this correctly, okay? So 0 less than or equal to 0 minus 1. 0 less than or equal to negative 1. Is 0 smaller than negative 1? No, it's not. That doesn't work. So this point does not work, which means I'm going to have to shade this side. If you wanted to just double check that, negative 1 less than or equal to 2 minus 1. Negative 1 is less than or equal to positive 1. Is that true? Is negative 1 less than positive 1? Yes, it is. So this point is part of my solution. So I'm going to shade all of this. So this is everything below my line. Okay, next one, number 6. In purple, 2x minus 3y is less than or equal to 6. We can graph this like y equals mx plus b, or you can graph this like it's a standard form equation, right? Remember, standard form equation, we find the x and the y intercepts. So to find the x intercepts, we plug a 0 in for y. So we get 2x is less than or equal to 6, which means x is less than or equal to 3. So my x-intercept is 3. 1, 2, 3. And to find the y-intercept, I'm going to get rid of this guy. Negative 3y is less than or equal to 6. Negative 3y less than or equal to... When we're finding the intercepts, the little inequality sign isn't super important, just the number, because we're either looking for this intercept or this, so we know where they go. We're not shading anything yet. All right, so I get y negative 2. So on my y-axis, I go down to negative 2. And since my inequality sign has a line under it, I know it's going to be a solid line. So I connect my two. Intercepts there to draw my line. And since this inequality sign has a line under it, it's a solid line. So now I have to shade, right? And I'm not sure which way to shade here because it's not in the right form. It has to be in the form y equals mx plus b for me to shade, because then y is the shaded part, right? So all I'm going to do here is, again, pick a point on one side of the line and pick a point on another side of the line. So I'm going to use 0, 0, and I'm going to use over 3 down 2. And whichever one works, I'll know that's the direction I have to shade for my line, right? So if I plug in 0, 0, 2 times 0 is 0. 3 times 0 is 0. 0 minus 0 is 0. Is 0 less than 6? It's not equal to 6, but is it less than 6? Yes, it is. So I know this is the point that works. So I know I'm shading in this side of my line, right? If we were to use these two numbers, plug them in here, we would find that it is not a true inequality statement. 3 is x, 2 times 3 is 6, minus 3 times negative 2 is negative 6. 6 minus negative 6 is 12, and 12 is not less than or equal to 6. All right, so this would not work. Has to be this 0.00, so we shade all of this. Okay, we've got 3 more, and then I'm done with this video, and then you have a part 2 to watch. All right, y is less than negative 1/2 x minus 3. This is in the correct form, so this is our shaded part. This tells us our line's going to be dotted, and this is our actual line. So let's go ahead and graph the line. We start off at negative 3, down 1, 2, 3. Great, and then my slope is negative 1/2. So I'm going to go down 1/2. I can go backwards. I can go up 1, backwards 2, up 1, backwards 2, up 1, backwards 2. So here's my line. It's going to be dotted because my symbol doesn't have the line under it. And then which way do I shade? It says the shaded part is less than the line. So I'm guessing down this way. All of this is below my line. Think of the line like water level, right? If it's under your line, it's below water level. So it would be this way, not this way. And again, if you're not sure, just pick a point here, plug it in. It should work. If you picked a point up here and plugged it in, it would not work. You're only supposed to shade the side that has the correct solutions. If you had a question, so this is supposed to be a dotted line. I didn't do a very good job of showing it. But if you had like a question on a test or a quiz that said, is the point negative 2, negative 2? This point right here. Is that a solution to this inequality? Well, that point lies directly on the line. So is it a solution to the inequality? No, because when your line's dotted, none of the points on a dotted line are included in the answers. Only the shaded regions included. If this was a solid line, then yes, this point would be a solution to this inequality. But it's just like saying when you say x is less than 4. Does that mean 4 is an answer? No, it can't be 4. It has to be anything less than 4. Same thing here. Y is anything less than this line. It can't be on the line. It has to be under the line. Okay, hopefully that makes sense. All right, and we've got another line here. I'm going to go ahead and rearrange this to get it in the y equals mx plus b form. So it's going to, if you do the math, it's going to be negative 4x plus 6. So this is going to flip 4/3 x, and it was plus 6. So it's going to be minus 2. So our equation's going to look like this. I just took this equation, I got y by itself, and I got this guy. Don't forget, when you divide both sides by a negative sign, your inequality symbol flips. Okay, so here's my line. The shaded part is going to be greater than the line, and it's going to be a dotted line because there's no line underneath the symbol. Okay, so let's start off by graphing the line. Negative 2, so I go down here to 2. And then my slope is positive 4/3. So I'm going to go up 1, 2, 3, 4 over 1, 2, 3. Great, and it's going to be a dotted line. Okay, and then which way do I shade? Y is greater than the line. I'm going to shade up this way. Remember, it's like water. Like think of it like a wave, right? It should be this way. But we can pick 2 points and try them out. So I'm going to try 0, 0. I always start with 0, 0. It's the easiest one to plug in. 0 is greater than 0 minus 2. Is 0 greater than negative 2? Is that true? Yes, it is. 0 is bigger than negative 2. So all of the... one thing too. Don't get lazy on your graph and go and shade that just like that. That is not shading. You have to shade your entire graph. Cover everything. Don't get lazy. Cover everything on your graph. If you want to just stop the corners of your graph, you can, but really it's an infinite solution. So our line keeps going on and on forever, and our shading is everything, right, on this side of the line. But you just have to do a full representation. Don't just do a little squiggle and think that's good enough. All right, last one. I promised. 3x plus 6y is greater than or equal to 12. I'm going to get y by itself, so that's going to be y greater than or equal to negative 3x with negative 1/2. plus 2. All right, so this is my equation. This is this. I just rearranged it. So now I know my shaded part is greater than or equal to my line. And I'm going to do this in green. Okay, so I'm going to start off for my line at positive 2 on the y-axis, and then my slope is down 1 over 2. Down 1 over 2. Down 1 over 2. And it's going to be a solid line. And then I have to shade, and the shaded part is greater than my line, so it should be all of this above my line. Think of this as water level. This would be below water. This would be above water, right? If I wanted to just test it out, here's 0, 0. If I plug a 0 in here and a 0, this is supposed to be next, and a 0 in here, is 0 greater than positive 2? Because if I plugged a 0 and a 0 in here, I end up with 0 is greater than or equal to 2. Is that true? No, it's not. So I can't shade down here where this solution is that I just plugged in. It's not a real solution. All of this side is your solution. Shade in your entire graph. You don't have to shade in like that stuff, but just within the parameters of the graph, you got to shade everything in. Okay, if you have questions on that, let me know. The biggest thing here is that you remember how to graph y equals mx plus b or standard form, and that you understand the shading part, right? The solid versus dotted line, that's the easy part. The shading and the graphing the line are the biggest thing, so you guys should be familiar with that. Okay, let me know if you have questions.